Okay, walk. I say when at on page 48, transforming quadratic functions. F of x equals -8, parentheses, negative bx minus h squared plus k. When the negative in front of the 8 reflects over the x-axis, when a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the b inside the parentheses, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. All right, let's take a look at the first example. All right, select the graph of the quadratic function below. Describe the transformation needed to get the graph of the function below from the graph of f of x equals x squared. So the first thing we're going to do is graph this. We're going to go to our calculator. We're going to go to add graph. We're going to type in 2 parentheses x minus 2 squared plus 6. All right, we're going to click on this to delete it. We're going to go to menu, view, grid, line grid. Okay, now we're going to come over here. Now the first thing you need to look at is the minus 2 moves the graph right 2, and the plus 6 is up 6. So we're going to look just at that. Okay, so here we go to the right 2, up 6. So this graph's okay. We go to the right 2, up 6, but this graph we know is facing upwards, so we can mark out B. Okay, here we go to the right 2, up 6, that's okay. We go to the right 2, up 6. The point should be right there. It's not, so you can eliminate D. Okay. Now, let's look at here. I'm going to adjust the window. So the x min is -10, x max is 10, scale is 2, y min is -20, y max is 20, scale is 4. So let's adjust the window. Okay. All right, so we're going to go to menu, window zoom, window settings. So -10, 10, 2, -20, 20, 4. Okay. So now let's take a look at our graph. Okay. Now it looks like it's this one, but you have to be careful. Okay. We need to look at the y-intercept of both of these. Okay. So we're going to press Control T, and our y-intercept is 0, 14. Okay. So let's write that down. Our y-intercept is 0, 14. Okay. So here, this graph is not at 0, 14, so it can't be A. This graph is at 0, 14, so the answer is C. Okay, go ahead and finish up that part. Now let's take a look at the transformations. The function of f of x equals x squared was vertically stretched by a factor of 2. Then the resulting function was translated 2 units to the right and 6 units up. Okay, let's take a look at the next example. All right. Select the graph of the quadratic function below. Describe the transformations needed to get the graph of the function below from the graph of f of x equals x squared. Okay, so the first thing we need to do is graph this. So we're going to go to On, New Document, No, Add Graph, 3, parentheses, x plus 3 squared minus 1. We're going to delete this, and we're going to go to Menu, View, Grid, Line Grid. Okay. So now let's take a look back at the graph. All right, so the plus 3 means we're going left 3, and the minus 1 means we're going down 1. Okay, so let's check each of the graphs for that first. So we go left 3, down 1, so A is okay. we go left 3, down 1. That's okay. C, we go left 3. This is not down 1. Down 1, the point would be right there, so it can't be C. And then here we go left 3, down 1. Our point is there. We can't be D. Okay. Now from there, we need to check the y-intercept. So we're going to go back to our graph and adjust the window first. So we're going to go to Menu, Window Zoom, Window Settings. Now, X-min is -10, X-max is 10, scale is 2, Y-min is -20, Y-max is 20, scale is 4. So let's do that. So -10, 10, 2, -20, 20, 4. Now when you do that, it looks like the graph is this one. But we need to check the y-intercept for each. So let's do that. So we're going to press Control T, and the y-intercept is 0, 26. Okay. So here, the y-intercept is not 0, 26, so it can't be A. Here, it looks like it's going up to where it would be 0, 26, so the answer is B. Okay. All right. Now let's take a look at the transformations. The function f of x equals x squared was vertical stretched by a factor of 3. Then the resulting function was translated 3 units left and 1 unit down. All right, let's take a look at the next example. All right, select the graph of the quadratic function below. Describe the transformations needed to get the graph of the function below from the graph of f of x equals x squared. Okay, so the first thing we need to do is graph this. So we're going to go to On, New Document, No, Add Graph. So then we have 1 divided by 2, parentheses, x minus 2 squared minus 4. All right. So now we're going to delete this. We're going to go to Menu, View, Grid, Line Grid. All right. Now, the minus 2 means we go right 2, and the minus 4 means we go down 4. Okay, so let's check each of the graphs for that. So here we go to the right 2, down 4, can't be A. Here we go to the right 2, down 4, could be B. Here we know the graph is facing upwards, so it can't be C. Here we go to the right 2, down 4, so it could be B or D. Okay, now let's adjust our window. So our x-min is -10, x-max is 10, scale is 2, y-min is -20, y-max is 20, scale is 4. All right, so we're going to go to Menu, Window Zoom, Window Settings, -10, 10, 2, -20, 20, 4. Okay, now we need to check the y-intercept. So we're going to press Control T, and our y-intercept is 0, -2. Okay, so this looks like we're at 0, -2, so we're okay on B. Here, the graph should be here for the y-intercept, and it's not, so it can't be D. So the answer has to be B. All right. Now, the function f of x equals x squared and vertically compressed by a factor of 1/2. Then the resulting function is translated 2 units to the right and 4 units down. Let's take a look at the next example. Select the graph of the quadratic function below. Describe the transformation you need to get the graph of the function below from the graph of f of x equals x squared. So again, we're going to graph. So we're going to go to on, new document, no, add graph. So that's 3 parentheses x minus 1 squared minus 4. We're going to delete this. We're going to go to menu, view, grid, line grid. Okay. Now let's take a look at the transformations. The minus 1 means we go right 1, and then the minus 4 means we go down 4. Okay. Now we know the graph is facing upward, so we can automatically eliminate A. Okay. Now let's look at right 1, down 4, we're okay. Right 1, down 4, we're okay here. To the right 1, down 4, we know we can eliminate D. Okay. Now we need to look at the y-intercept. Okay. So we're going to go back to our graph, but first let's adjust our window. X min is negative 10, max is 10, scale is 2, negative 20, 20, scale is 4. Okay, so menu, window zoom, window settings, negative 10, 10, 2, negative 20, 20, 4. Okay, and now we're going to press Control T. We're going to look at the y-intercept, which is 0, negative 1. Okay. Now, 0, negative 1 is about right here. Okay, so it can't be B. 0, negative 1, we're good there. So the answer is C. Okay. All right, let's take a look at the function f of x equals x squared was vertically stretched by a factor of 3. Then the resulting function was translated 1 unit to the right and 4 units down. Let's take a look at the next example. All right, select the graph of the quadratic function below, give the minimum or maximum value and the axis of symmetry. So first things first, we're going to graph this. All right, so we're going to go to add graph. We're going to graph x squared minus 6. Okay. Now we can see the graph went down 6. So we know the minus 6 means it goes down 6. So this graph went up, so it can't be A. Here, this one went down 6. So far, the answer is B. Here, this didn't go down, and this didn't go down. So now let's adjust our window. So negative 5 to 5, scale 1. Negative 7 to 3, scale 1. And let's make sure that B is correct. Okay. So menu, window zoom. Oh, wait. Let me escape and let's delete that first. Menu, view, grid, line grid. Menu, window zoom, window settings. So negative 5, 5, 1, negative 7, 3, 1. And let's double check the y-intercept. Control T. 0, negative 6. Okay, 0, negative 6 is right here. So the graph matches B. All right. Now, the function minimum is -6 right here, okay? And the axis of symmetry is x equals 0 right here. The axis of symmetry cuts the graph in half. There's your axis of symmetry. And this right here is your minimum value. Y equals -6. The minimum is always the y value, okay? So axis of symmetry is x equals 0. All right, let's take a look at the next example. All right, select the graph of the quadratic function below. Give the minimum maximum value in the axis of symmetry. Okay, so we're going to graph that first. So on, new document, no, add graph. So parentheses, x minus 5 squared. We're going to click delete that. Menu, view, grid, line grid. Okay, let's go back to our. Now, the -5 means we go right 5. So let's check. Right 5, we're okay. Right 5, the point would be right here. It's not B. To the right 5, our graph would be right there. It's not C. To the right 5, our point should be right there. It's not D. So the only possible option is A. Okay, but let's adjust our window. So -5 to 9, scale of 1, -1 to 11, scale of 1. Let's make sure. So we're going to go to add graph, and then we're going to graph parentheses x minus 5 squared. Apparently we lost the graph, so we'll just get it back. Menu, view, grid, line grid, and then menu, window zoom, window settings. So -5 to 9, scale of 1, -1 to 11, scale of 1. Press OK. And we have our graph. It matches. We're good. Okay. Now, the minimum point right here, and that's what this is a minimum, is the y value of this point. So that point is 5, 0. But the minimum is the y value. So y equals 0. Okay. And our axis of symmetry is right here at x equals 5. Okay. So the function has a minimum value of 0, and the axis of symmetry is x equals 5. Okay. All right, let's take a look at the next example. Okay. Compare the given graph to the graph of the parent function f of x equals x squared. Describe how the parent function must be translated to the graph shown below. Okay. So the graph translated to the right, 1, 2, 3. So the graph translated the function 3 units to the right. Okay. Right. Last example. Select the graph of the quadratic function below. Give the minimum maximum value in the axis of symmetry. So we need to graph this first. So we're going to go to on, new document, add graph, and then we're going to graph negative, parentheses x plus 1 squared plus 6. All right, and we're going to delete this. Okay, we go back here. All right, now we know it's facing downward, so we can eliminate already A and B, and we know that it is a maximum. Okay. All right. Now, we can actually find the maximum by doing this. We're going to go to Menu, Analyze Graph. We want maximum. We're going to click, drag across. And remember, the maximum is the Y value, okay? So our maximum is Y equals 6 from the point -1, 6. So let's graph that point. So -1, 6, that's okay. -1, 6 is right there, so it can't be D. So the graph has to be B. But let's adjust our window just to double check. All right, so we're going to go to Menu, Window Zoom, Window Settings, and then it's -10, 10. Menu, Window Zoom, Window Settings, -10, 10, 2, -20, 20, 4, Menu, View, Grid, Line Grid. Okay, so that matches up. Okay, so we have our maximum, and our axis of symmetry is right here at x equals -1. Okay, so the function has a maximum value of 6 and the axis of symmetry at x equals -1. All right, go ahead and finish up your example, start working on your assignment, and have a wonderful Wildcat day.